Alright, so we're going to do problem 8 out of chapter 1 of Rosenlicht. So we have a function f from x to y, and part A we want to show it's 1 to 1 if and only if f inverse of f of a is a for all a is subset of x. So for part A, I'll just note that in the previous problem, in problem 7, we showed it's always the case that so let me look. It's always the case that f inverse of f of a, this always contains a. So this is always true. That was shown in problem 7. So now we'll just do the two implications. So for the forward implication, if f is 1 to 1, then we want to show, well, we just need to show this other inclusion for the equality of sets. So this is what we want to show. So say that we have x is in f inverse of f of a. So what this means, since x is in the preimage of f of a, we have that, so this implies that f of x is in the image of a under f. But this just means that there exists some element, say y, in a, such that f of x is equal to f of y. That's just what it means for f of x to be in the image of a under f. That is, there's some y in a, where f of y is f of x. But then using that, this function's 1 to 1, so using f is 1 to 1, this implies x is equal to y. But we know that y is in a, so this implies that x is in a. And we have this inclusion, and we showed in the previous problem we have this inclusion, so that gives us the equality. So that's kind of the first part. Now, for the backwards direction, we're going to go by contrapositive. So we're going to do the contrapositive. So, namely, we're going to assume that, f is not 1 to 1. And then we're going to show that this equality does not hold. Namely, we'll show that this inclusion is not true for some subset A. And so, since f is not 1 to 1, this implies that there exists some x not equal to y. Both of these are elements of A, such that f of x is equal to f of y. So this is just what it means to not be 1 to 1. And so now what we can do is, if we consider, let A, so if A is just the set containing x, then if we look at f inverse of f of a, if we look at this set, well, clearly x is in this set, but y will also be an element of this set, because f of y is equal to f of x. But this is not equal to x, so we have that f inverse of f of a is not equal to a, because this contains some element not in a. So that proves the backwards direction. Alright, let me get a new sheet of paper and we'll do the other. So part B is, again, we'll note that in problem 7, we showed that it's always the case that f of f inverse of b will contain b. So for showing, oh, let me focus the camera. Okay, so for showing this equality, we just need to show that the other inclusion is true. So let's do the forward direction. So if f is onto, what does this mean? So we're assuming f is onto, and we want to show that, namely, f of f inverse of b is contained in b. So we want to show this other inclusion. So what we could do is we can say let y be an element of b, and since f is onto, and here note b is going to be a subset of y. So since f is onto, we know that there exists some x in the set x with f of x equal to y. That's just the definition of what it means to be onto. So if we look at this, so this tells us that since f of x is equal to y, we're going to have that x is an element of the pre-image of y. And this is, of course, going to be a subset of the pre-image of b, because y is contained in b. And so, y is some element of b, and we want to show that it is an element of f inverse of b. And that's exactly what we get, because y is in f of f inverse of b, since y is equal to f of x, where x is in the inverse image of b. And so that proves the forward direction. And then proving the backwards direction, we do a very similar thing as last time. So the contrapositive. So say f is not onto. So if f is not onto, what does that mean? And then we want to show that b is not a subset of f inverse of b. So this is kind of our goal. So f is not onto, what that means is, that means that there exists some element, say y, in the set, in the codomain, so say y in y, such that for every x in x, f of x is not equal to y. So there's no element in our domain mapping to y. So what we could do is we can just, so we want to show that this is true, that we don't have this inclusion. So we can consider, just take b to be equal the set containing y. And the entire idea here is, because we have this condition, b will not be a subset of f inverse of b, because f of f inverse of b, it's going to be an element of the range, but y is not in the range of the function. So this tells us that this is not true, and hence by the contrapositive we have that this statement is true. And that's how you prove this. Alright, thanks for watching.